What's up, everyone? I just want to give you all a quick look through the flow device here before I seal it up. I didn't want to spend too much time on my video going through all the steps to put this together. I just wanted to focus more on the laminar and turbulent flow in my video. So if you want to look in here, it's kind of difficult to see, but beyond the window mesh here, we've got about 750 wire mesh, or 750 coffee straws in there. This is the wire mesh, but the center part of it is mainly made up of the coffee straws. Same thing on this end. This is like the kind of the receiving end, if you will, where the water hose is going to be hooked up to. We've got three, kind of scouring pads, whatever you want to call them. More wire mesh here, and this is where it's gonna initially flow, and this will be the exit flow right here. And yeah, I just wanted to give you all a quick look through it before I close it up. It should look pretty nice here, so we'll get to it. All right, everyone, so we've got our laminar flow nozzle here. I just kind of wanted to go over what I hoped you can learn from my video today. So the purpose of this here is to, we're going to hook it up to your standard garden hose, and hopefully the exit here is going to be a nice laminar flow. And now what I mean by laminar flow is, it's going to come out real smooth. The idea behind laminar flow is to have no turbulence in your in the fluid that's flowing through your device, through your your pipe. And by what we've created inside here, the idea is to slow the water down, create multiple layers in the pipe here, which is ultimately going to create our laminar flow. And once we get that going and get a good look at that, we're going to see how that works for us. I'll talk a little bit about Reynolds number, and we're going to calculate Reynolds number, and you can learn all about that. That's a big thing in fluid mechanics. So let's get to it. All right, so I just want to show y'all what the water is going to look like coming out of your standard garden hose versus before we hook it up to the nozzle here, just to kind of get an idea of the differences and what it's going to look like for you. So here we go. Hang on, turn that up a little. All right, so bring that over here. So you can see it looks like a nice smooth flow, which is what we're gonna have, but as you can see, it's a little cloudy, and that's essentially what we're gonna try and get rid of here in the nozzle. So just get a good look at that so you can see a difference before we hook it up here. All right, so we've got our hose hooked up to our homemade built laminar flow nozzle here. And essentially, to create the laminar flow flowing through this device is when you've got a ton of different parallel layers in here. So this thing's got a lot of window mesh and straws, real tiny coffee straws in here. So we've essentially created a very high amount of parallel layers, and when the water is going to flow through there is what's going to create the laminar flow, and we're going to see a real nice smooth flow coming out of the end here. So we'll turn it on. And there we go. So got a little water air bubble in there possibly. And you can tell the difference from when it was hooked up to the garden hose. You can see how smooth it is. You can almost see straight through it. And that was the goal here when we built the nozzle, and it looks really good. Yeah, so we've got the flow going here, and man, it looks good. That is exactly what laminar flow should look like. You can almost see, literally see straight through it. Looks real nice. All right, so we've got our laminar flow going here. It looks real good. The next thing I want to talk to y'all about is something called Reynolds number. And I'm going to calculate that for y'all here later in the video, but I just wanted to give y'all a quick description of it. So the Reynolds number is defined as the ratio between the inertial forces in a fluid and the viscous forces. And it's a very important number in fluid mechanics, and it's also dimensionless. So it has no unit, it's just a number, and it helps you predict the flow patterns in different fluid flow situations. So what we're gonna do is calculate the Reynolds number of this flow, and it's a real simple formula. I'll show you a picture of it here in a second. It's the density of the fluid multiplied by the velocity of the fluid multiplied by the diameter of the exit flow here. So that's a real small hole we've got there. It's only about 5/8 of an inch, but we have to convert that to millimeters or so. And that's all divided by the viscosity of the fluid. So that's where you get the inertia forces divided by the viscous forces. And we're gonna do that here in a second, so you'll have an idea of exactly what Reynolds number looks like. All right, so I've written down here the calculations for the Reynolds number for what we've done today. As you see, I have the formula here. RE, Reynolds number, is equal to the density of the fluid times the velocity times the diameter of our pipe divided by the viscosity of our fluid, which is water today. As you can see, it's a real low number. Viscosity of water is one of the lowest, I believe, that you can get, if not the lowest. So our density of water is equal to 997 kilograms per meter cubed. We calculated a 1 meter per second flow rate. The diameter of our pipe was 4 inches, and we converted that to meters. And our viscosity, again, 0.0091. And we come out to a number of 11,175. And just a reminder again, it is a dimensionless number. So no unit, it's always just one big number. And this is a pretty good number here for Reynolds number as far as creating just a homemade built device. Some that are created in factories and whatnot can get down in the 2,000 range, and those look real nice. So to get this here at home is I think pretty good. These numbers can, they go into hundreds of thousands depending on your flow. You get into turbulent flow and you'll see 100 to 250,000 Reynolds number. And so the lower that we can achieve for laminar flow, the better. And this is what I was able to come out with. So yeah, I think that's a pretty good number. All right, so I just kind of wanted to recap and give you kind of another rundown of our flow nozzle here. Obviously, here's our inlet valve, and got a 4-inch diameter pipe, about a 3/4 inch hole here for the inlet nozzle, followed by 3 scouring pads and some window mesh. And then here in the middle, we were able to get 750 coffee stirrer straws, and that's what kind of creates those parallel layers I was talking about earlier, which kind of helps slow the flow down and creates the laminar flow with all those different layers. And followed by 2 more, I know you can't see in there, it's got 2 more layers with about 1 inch gap of the window mesh in there, and followed by an aluminum can cut out here, drilled a hole through it, get a real smooth edge in there for the exit flow. And real nice airplane flying over right now. And that's where it exits right there, and that's essentially what helps us create that nice smooth laminar flow. So all in all, only costs about 30-40 bucks to build, and only a couple hours worth of your time. So it's real neat. It's pretty cool. It's a lot of fun. So and a little black spray paint. So yeah, that's it.